Hello, this is Dr. Thompson from Taylor University, and I'm going to give you an introduction to W substitution with this example here. This is the integral of x times cosine of x squared dx, and this is going to be a little tougher than those integrals you did at the beginning of Calc 1. It's going to require a new technique, and the reason for that is that we've got a product and we've got a composition, but there's no chain rule, there's no product rule, there's no quotient rule in integration, so this is a little tougher. And so this technique is going to focus on the composition part and the fact that we don't know how to do that. We do know how to integrate cosine of w, so that is our goal, to do that instead. So I said w because I'm going to make a change right here. So you can see here I'm going to make w x squared so that I have just cosine of w. I'm using a new letter so that I don't confuse myself, and hopefully that'll make the integral look a little easier. So let's go ahead and make that change. So at this point, I have x cosine of w dx, and that looks a little better, except now I've kind of got mumbo-jumbo at this point because I have x and w, but the differential is dx, and that says I'm integrating with respect to x, and so w doesn't make any sense at this point. If I want to keep going with what I've done, if I want to integrate cosine w, then I want dw at the end, not dx. But remember, the connection of where you've seen those differentials before is when you did derivatives. If I took the derivative of this new equation I made, w equals x squared, I would get dw dx, both involved. So let's go ahead and do that. So here I've taken the derivative of this equation. The substitution is an equation in its own right, has a derivative, and that derivative is 2x. I've already split the differential. I have dw over here, and I already multiplied over here by dx. That's a common time saver for this technique because you're always going to do that. You're always going to split that differential because I'm really trying to solve for this dx. I would like to take that dx here and replace the one that's in the equation. So to do that, first I need to solve for dx. So let's do that. So in this step here, I have divided by 2x. So now dx, which was on the right side here, is going to equal dw over 2x. And now my goal is to replace dx with dw over 2x right here. So let's go ahead and do that. All right, so now our integral is almost where we want it. We have x cosine w, we have dw, but we're dividing by 2x. So x is still involved, but fortunately for us, we can cancel those x's because one's in the numerator, one's in the denominator. And so now the only thing in the denominator is that constant, which we can just kind of take out of the integral. So let's do that. It was on the denominator, so it's really just a 1/2. So I brought that outside, and I have 1/2 times the integral of cosine w dw, which is an integral I can do. We learned that one in Calculus 1, so let's go ahead and do it. So that's 1/2 sine of w plus c, can't forget that. Except now we're kind of done, but we didn't start with w, we started with x, so we should really change our variable back. We kind of use the w as a temporary fix to make the integral easier, but then we have to switch back when we're done. So remember, w was x squared, so right here we're going to have 1/2 sine of x squared plus c instead of sine of w. Now our last step is just to check that this actually worked, so let's do that by taking the derivative, because that's how we reverse taking the antiderivative. So here we're going to take the derivative of our answer here with respect to x. 1/2 stays for the constant multiple rule. Sine becomes cosine, and because we're going to use the chain rule, x squared stays where it is, and its derivative 2x is what I multiply by. And then of course the constant c becomes 0. And now if I cancel the 1/2 and 2, they become 1, and I bring the x out front, I get x cosine x squared, which was my original integrand. So that shows that I have the right answer, that it really is an antiderivative of what we began with. And so that is one example of how to use w substitution to make integration easier.